Okay, folks, one more page to go. Page 4 of the final exam review, part 2. There are 4 questions on page 4, so let's get started with number 12. I need some new chalk. Let's use this piece right here. Okay, number 12. Okay, number 12 is, let's see. So we start with a car. Car has a mass of 1,000 kilograms. It's moving at 17 meters per second. It comes to a stop when the brakes are applied. All of the force, right, that caused the car to stop was applied by the brakes. The car skids 30 meters before coming to a stop. Part A, how much work had to be done to stop the car? So the key concept here is if you want to change the energy of an object, you've got to do that amount of work on the object. The amount of work that you do is equal to the change in an object's energy, right? So if we want to answer the question of how much work was done, we need to figure out how much energy did that car have when, right before the brakes were applied. All the energy is kinetic energy. 1/2 mass times velocity squared. Okay, if I let's see, if I multiply this out, what do I get? 17 times 17 is 289 divided by 2 is 144.5 times 1,000 is 144,500 joules. Okay, so that is the amount of work that was required to get this car to stop. Okay. Part B. Okay, the same car, so it's the same mass and the same brakes and everything, was moving at 50 meters per second. If the maximum amount of force possible is exerted by the brakes, then what will be the stopping distance for the car? Okay, so to answer part B, okay, we actually need to go back a little bit, back to part A, and figure out what was the force. Okay, how much force was actually applied that basically contributed to all of this work that caused the car to stop. Okay, the way we can get that amount of force is by remembering that work equals force times distance, right? And it said up here in situation A that the distance, right, it took 30 meters for the car to come to a stop. Okay, so we can solve for the amount of force that the car is able to apply by solving this equation. Okay, 144,500 equals force times 30. Divide both sides by 30, and you get 4,817 newtons. All right. Okay, so this is the amount of force that the car's brakes can apply. Now the car is moving faster, so we can figure out what is its new kinetic energy. So if the car is moving at 50 meters per second, okay, how much kinetic energy, or in other words, how much work is going to be required to get this thing to stop? I could do 50 times 50 times 1,000 divided by 2 is, wow, that's 1,250,000 joules. Okay, that's how much kinetic energy the car has. That's also how many joules of work is going to be required to get it to stop. Okay, the amount of force that the car can apply to get it to stop is this number right here, 4,817, 4817, and it has to be applied over a certain distance, and that's what we're trying to solve for, right? So if I take 1,250,000 divided by 4,817, I get 259 meters. Okay, so it's quite a bit farther than the 30 that it took to get it to stop when it was moving 17 meters per second that's just how much of an impact a change in velocity has on stopping distance. Okay. The answer to part B, 259 meters. Okay. All right. That's a wrap for number 12. How about number 13? So number 13 is how much work is it to lift a 15 kilogram sack of potatoes vertically? There's potatoes, right? Okay, we're trying to lift this vertically a distance of 3.5 meters. Okay, so 13. All right. Okay, so work is force times distance. Okay, we know the distance. Okay, we're trying to lift this sack of potatoes a distance of 3.5 meters. What about the force though? We know the mass. Okay, mass is equal to 15 kilograms. Okay, so the actual weight of these potatoes, or the force that's being applied downwards, is equal to mass times acceleration, where the acceleration is 9.8, the acceleration due to gravity. Okay, so the force that needs to be applied to get this sack of potatoes to move up is 9.8 times 15. That's 147 newtons, which gets put in that. That gets put into that. 147 times 3.5 is 514.5 newtons, or joules. So work equals 514.5 joules. Okay? And that is a wrap for number 13. Okay? Great, great. 2 more to go. Let's look next at number 14. Okay, number 14. What's the deal with number 14? Okay, Josie drags a sled full of stuffed animals at a speed or a velocity of half a meter per second for 3 minutes using a force of 12 newtons. How much work has she done? Okay. So again, coming back to the notion of work equals force times distance. Okay. The force we know is 12 newtons, so that's cool, but what is the distance? Well, distance, I think we have to get the distance by going back to the fact that distance equals velocity times time. Okay, she's dragging this wagon full of stuffed animals at a rate of 0.5 meters per second for 3 minutes. So I gotta do a conversion real quick. 3 minutes equals 60 times 3 is 180 seconds. Okay, that's what goes in here. So the distance is actually going to be 90 meters, right? Velocity times time in seconds is 90 meters for the distance. Okay, so the work is equal to 12 times 90 times 90 is 1,008. Okay, joules. Okay, and that is the final answer for number 14. Okay, one more to go, folks. One more to go. What is the deal? Number 15. Let's see. All right, number 15. What is this about? So, number 15, a 55 kilogram bicyclist on a 7 kilogram bicycle speeds up from 4 meters per second to 20 meters per second. How much work was done to increase this kinetic energy? So, remember, work equals change in energy, right? So if we compare the situation at the beginning, where the KE, the kinetic energy, was equal to 1/2. The mass of the total situation is 62 kilograms times 4 squared. Okay, This is the amount of kinetic energy that we have before the acceleration, the start and the after, right? So in the end, the kinetic energy has become this. 1/2 times 62 times 20 meters per second squared, right? So to figure out the amount of work that it took to speed up, I just need to figure out the difference between these two numbers. So let's do that. 25 times 62 times 16 is 496 joules. Okay. And over here, 0.5 times 62 times 400 is, wow, 12,400 joules. Okay. So if I subtract those, I'm going to get the amount of work required. That's 11,904 joules of work. And that's a wrap. See you next time, folks.